And we can also name the components if we want using a dictionary for the tensor for the from tensor slices. So in this case, we just have this dictionary where we name our x and y, and we name them xtr and ytr. Now, the data sets have attributes. They have output types and shapes. So if we run this, then we can see these. We have ytr is a float 64 and xtr is also a float 64. And then for our output shapes, right now we just have this empty shape for y because it's zero dimensional. And then we can see that for xtr we have this dimension 3. So really this is just because it's reading a single entry in our data set and it's saying that we have 3 features there. While this is just a very basic method of reading in data sets, I just want to point out that there are other methods, and we'll actually see the usage of one here soon. A couple others are the TF record dataset. This one is because you can actually save TensorFlow data formats. So any TensorFlow data sets that you create, you can save them and you can read them back in later. There's also a text line dataset, which is good for reading anything that has text in it, so any kind of textual based data. And as well, we're going to see a CSV method. Now, iterators are something that you need in order to actually move over or iterate over a data set. They're generally pretty easy to create, at least the one-shot iterators are. So we're going to have an example here. Let's just see the length of our training data. And we're going to create a data set, we're going to create an iterator on our data set training 2, which is the one that we had the variable names, or the component names. So on that data set, we're going to use the method make one-shot iterator. So that's just going to create an iterator for us that operates on our data set, which was training 2. Then we're going to create a next element operator, which is a method we call on our iterator, which is getNext. So every time we call next element, that's going to get the next element in our data. And remember that an element is just one observation, or in some cases it can actually be an entire batch. So here we're going to get next, which will get us just the first row inside of our data. Right here, and this is the reason I got the length of our XTR, we're going to loop over the range 131, and we're going to get the value from our next element. Let's make sure though that we have our session. It may already be open, but just in case you haven't opened it yet, just do that. And so we're going to we're going to print out the value. And remember that we named them. So now I'm going to call the key for that, which was ytr. We're just going to print the y values as we run or iterate over this. So as you can see, it's printing out all of the y values within our data set. So this next element, it's essentially calling over our data set once. So throughout the whole data set, it's just going to iterate over it and print out or return every single value that we get. Value is actually x and y, which is why we're calling the key right here. Now, if we were to go beyond our 131, then we would get an out of range error, which is end of sequence. So I'll show you how to handle that. All you need to do, we're going to create this iterator again, by the way, and also the next element. So now I set the range to 132, which is going to print all of our y values, but then once it hits the last element, once it hits 132, we'll be out of range. So we're going to use try and except. So on the except, we have tf.errors.outofrangeError. And we really don't need to call as e. If you were to print e, it would print out a long error. So we're just going to print no more data. So let's go ahead and try that. And we can see it prints out all the data as usual, but at the bottom we have no more data because the iterator ran out. So that's a brief illustration of iterators. And as I mentioned, there are several other types. This one is just the easiest to use by far. And actually, you know what? I should mention this is a good example of why it's a one-shot iterator. While you can call repeat methods on it, it's just so basic and it's really just meant as a one-off. So we iterated through it once and no more data. Again, we could repeat on it, but we're not going to cover that right now. Now we're finally on to pre-processing. So this is kind of the whole goal of this last part of the video, but we kind of had to work up to it. Before we cover anything, you'll see here that I have df to CSV. So I've just created a CSV file of all of our data. This was from the initial data frame where we created it. Again, if you don't have this, then go ahead and recreate from the previous notebook and go ahead and save that to CSV so that we can illustrate loading in the CSV as opposed to the NumPy arrays. There are two main steps to our pre-processing. We have define your transformations, and then we need to use this map method on our data. So we have our dataset object, and we call the map method on it, where f, of course, is just our transformation. So we're going to start with something really basic. First, we're just going to work with creating a transformation. And we have a nested function here. We have our input function, which is just going to return our features and our label after it's been loaded and transformed. So again, this function is just going to load the data in, transform it, and it's just going to return it as two components of a data set. The nested function that you see here, this is where we're going to actually load the CSV and we're going to add noise to it. The reason we have this nested function is because we actually are going to use an iterator, because loading these in, we actually need to do these transforms and loads one line at a time on our data, or one element at a time. So let's take a look at the arguments. We have CSV file, that's just the file name, so that's going to be a string. We have feature names, we're going to map the feature names for all of the columns. And then noise equal true. For our transform, we're just going to apply noise to our data set. So we can set that to false if we want, and then it will not apply that transform. Remember, you can apply just about any transform you want, as long as it can be done within the graph of TensorFlow. If you want to create other transforms, you just need to do that outside the graph, depending on what kind of processing you have going on. Now, inside the decode CSV add noise, line is something that we don't need to define ourselves. We just need to have that in there as a call. That's something that is going to happen in the map area. Map is going to handle that part for us. And then noise equal noise, that's just say whether or not it's true. Now, parsed line, this is where we're just going to get a single line from our CSV. And that's the whole point of line here. That's going to be the line number that's going to be called from our map function. This right here is just a set of default values. We have one for each column in our data set. And you need to make sure that the data types match up. That's why we're using a decimal here. Otherwise, we could use just integers or strings. Now, if you leave any of these empty, then that's just going to signify to TensorFlow that that column is required, so it's not going to fill it with default values. Here what we're doing is we're just getting from our parsed line what our label is. So the data set that we saved has the label included, and that's the last column inside of it. So from our parsed line, we're just getting the label from that last element. And then we just make sure to delete it so that we can set features equal to parsed line easily. And it's not exactly necessary. We could use slicing again on that, but we went ahead and deleted that. And now here's where we perform our transform. So if noise, so in that case, if noise is equal to true, then we're going to redefine features, which is going to use the TensorFlow addition operation, where we're going to add some random noise to features, and that random noise is created using the TensorFlow random normal method. The shape, of course, needs to match length.features. It actually doesn't exactly. We could make a scalar and just give it a shape 1 and add it to the same noise to all of the elements, but this way we're going to create a little bit of noise that's different for each one. We're going to set the mean to 0 and the standard deviation to 0.1. So that's where we apply our transformation. Again, we can create just about any transformations we want within reason. You can go ahead and ignore the commented parts. So this decode CSV add noise is going to return what it's created, the features and the label transformed. So dataset, this is where we actually define the TensorFlow dataset. We're going to use the data text line dataset method, and of course we're going to feed the CSV file name to that. That's where it'll read that text file in. The skip one is just so that it'll skip that initial row that gives us the column names. If for some reason you save it so that it doesn't have the column names, then you don't need the skip. One thing actually that I should mention is the index false on the data frame, index equal false. That's necessary to prevent creating that erroneous row or that erroneous column. Otherwise, inside the CSV, we would actually have an extra column there with the index names, and we don't want that. The default is true for pandas. The map function is what handles essentially the decode and the noise for us. That handles really any transformations. So the map, again, is what creates, it's what feeds in this line for us. And that's why we don't need to have any arguments for our CSV add noise. We just pass line. That's passed automatically by map, I should say. So this is going to iterate and create one line at a time and feed it into this data set. And then we have an iterator again. This is so that we can actually iterate over our entire data set. So we have the iterator get next. And that way, every time we call features label on iterator get next, then we're going to get the actual next element in our data set and return them. So if we go ahead and run that, then we can illustrate this. What we're going to do is create an iterator that is going to pass the data.csv as our CSV file to our input function. So this way we can iterate over our input function. Right now we're just going to set noise equal to false so that we can illustrate that this is actually making a difference. We're going to show it with and without noise. So let's run over this. And right now, this is just going to return the very first row. That's all it's going to do, or the first element. So we have the first three pieces, those are the columns for our features, and then we have this extra list here, which is our y value. So that would be the age of 23. Now if we set noise equal to true, then we can see that now we have some noise added to this. So that's just to illustrate that. And there, again, is a lot that you can do with this. I recommend exploring, playing around with it, and trying different things. A lot of trial and error is going to be involved for really getting the hang of something like this. With that out of the way, let's go ahead and move on to the batching data. And it looks like I have some erroneous text here. You can ignore that. That's slightly awkward. Okay, so let's see. There are only a couple small changes that we need to do with our, or a couple of small changes to our input function. One of them is we're just going to add this argument batch size. And everything else is the same all the way up until here. And then we've added this one piece, this one line of code. Dataset equal dataset.batch, and we're going to pass the argument of batch size to this. So what this is going to do, as far as iterators go, it's going to allow us to iterate over our data set, getting batch sizes, getting chunks of batch size. And of course we have our iterator again, and we've just renamed the features and the labels. We've preceded them with batch. So that's it. That's really just the same thing. And so returning that, now we can print out an illustration. This time, even though we set our default to 16, I just passed a batch size of 10, a little cleaner for printing, I suppose. And here we have this with TF session as S. I should actually point this out. We used this once before up here. So what with TF session does is, just like with open in Python, is it creates this session for us just temporarily, and we're going to call it S. This is like where we created ses equal tf.session, but that's a little more permanent, whereas this one, it's going to perform whatever is inside the with, and then it's going to close our session. So that session is very temporary. And so here I have batch equal s.run next, so we run over the iterator. Now remember, this is only going to print out our first batch for us. So we're going to print the x component of our batch, and we're just going to leave an extra line in there, and then we're going to print out the y component from our batch. So if we run that, we can see we get this tensor, which are the features, and then we have this one right here, which represent the labels. So that's it as far as data preprocessing goes. Again, they are the basics, but it's extremely time consuming, and again, there's a lot of depth to it. I recommend digging into the documents, but you can also wait for future videos, and in those we're going to be covering some more advanced topics, and you'll definitely be seeing some of this later.